Hello guys, welcome to the course in Organic Made Easy. So what are we going to learn today to make the study of an organic chemistry easy? Well, it is going to be the thermal decomposition reactions. Thermal means heat, decomposition means breakdown. So we are going to study how the various salts and acids they are affected by heat. What are going to be the products that are formed? Well, this is going to be the third lecture that I'm going to be putting on thermal decomposition. We've already discussed about the thermal decomposition of metal carbonates, bicarbonates, hydroxides, and also a lecture on ammonium salt thermal decomposition. They are really very important. And today we are going to discuss the thermal decomposition of metal nitrates, and there are going to be more coming up. Why? Well, look at this question if you've watched the previous lectures, you've watched this question in those ones also. So which of the following on thermal decomposition yield a basic as well as an acidic oxide? And here you have four choices, four ionic salts. And these four ionic salts, there are four cations, four anions, and with these four cations, four anions, you can make more combinations and then we can have more metals forming cations and there can be more anions. So many compounds possible and many thermal decomposition products possible. So just to make the study easy, because this is really very important, we are discussing these as inorganic made easy lectures. All right. So this is going to be really very important for you to watch all of these lectures because this is going to be very helpful to you in the examination as you will be seeing more questions at the end of the lecture too. Okay, so let us begin the learning. I am Dr. Ritu Johar from the channel H2O, the A to Z of chemistry, and I hope you're going to enjoy your learning with me. So first of all, let us quickly define what do we mean by thermal decomposition. Although we've watched the previous two lectures, they know, but for those who are watching this lecture as the first lecture and will be watching the others later on, well, let us quickly do that. So thermal decomposition is going to be the decomposition of a compound, a breakdown of a compound on heating, forming two or more products. For example, we have lithium nitrate. When we are going to heat it, it is going to give us lithium oxide, NO2 gas and oxygen. So we have a compound, we are heating it and getting two or more than two products. So that is thermal decomposition. So do remember, whenever it is going to be a decomposition reaction, there will be only one reactant. And the reaction is always going to be an endothermic reaction because we have to break the bonds present in between the various atoms of the compound. And for breaking the bonds, you're going to need energy. And when this energy is in the form of heat, it is going to be called as thermal decomposition reaction. So now let us see how we are going to learn the thermal decomposition of the metal nitrates. So here what you have to remember is that the anion is going to be common for all these compounds. But what is going to be different? It is going to be the metal that is different. And we have so many metals spread throughout the whole of the periodic table. Group 1 metals, then we have group 2 as metals, and then we have D block, F block metals, and then even in the P block, the top ones, they are non-metals, but down the group, they are going to be metals. For example, we have lead, we have tin, we have metals even in the P block. So throughout the whole of the periodic table, we are seeing so many metals. And then there are nitrates and then the decomposition reactions. How are we going to learn them? Do we have to learn each and every? No, not at all. What are we going to do then? Well, we are going to classify the metals into three categories and we will be learning the decomposition reactions for these three category nitrates and the work is going to be done. This is going to be that simple. And the good news is that all those who have learned my lecture on metal carbonates, bicarbonates and hydroxides, well, the classification is the same. Yes, you already know the classification. So what was it? And for the first time viewers also, let us see what are the three classes. So we have three classes, that is class 1, class 2 and class 3. Class 1 is going to be all the group 1 elements except lithium. So sodium, potassium, rubidium, cesium, all of the alkali metals except lithium are class 1 metals. Then we have class 2, which is going to be all the metals that you can think of except the metals which are going to be in class 1 and in class 3. And what is class 3? It is going to be silver and mercury. Do remember, here we are not going to include gold and platinum because they are noble metals. If they are going to have some compounds, they are going to have very few ones. If there will be some compounds, we will be putting them into class 3 with silver and mercury. So the products will be just like that. Okay, so just remember this. We have class 1 now as the alkali metals, except lithium. That is very important. Lithium will go into class 2. Then we have class 3 to be silver and mercury. Just omit out gold and platinum being noble metals. And then the rest, all the metals, any metal it is asked to you that it has a nitrate, you have to tell the thermal decomposition reaction. You are going to just remember what is the product for this class metals. All right, now even to make your work more simpler, I am going to even make you remember this from something that you have learned already in your junior classes. Let us see what. So the trick to memorize the three classes is to remember the activity series that you learned in your junior classes, probably 9th or 10th. Well, what was that activity series? The activity series is we have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead being more active than hydrogen. And then below hydrogen, we have copper, mercury, silver, gold, platinum also. Right? So we have learned some mnemonics also for that. I hope you must have also learned. I am just sharing one with you. You must have learned another one. That does not matter. The only thing that matters is that you should know this activity series. So the mnemonic I use is, please stop calling me a zebra. Instead, try learning how copper met silver. All right. And from this, you can make all of these. Now, how are we going to divide all these three into the three classes that we have learned? Look at first of all potassium and sodium. These were in which category? Group 1 elements except lithium. They are class 1. So you can just remember along with potassium and sodium, the elements below them in the group 1, that is rubidium and cesium, they will also be class 1. Then last 3 is going to be mercury and silver, the lowermost, the topmost, the lowermost, and the rest, all of them, they are going to be class 2 metals. So any metal which you can think of except the group 1, right? Excluding lithium, I am repeating that again and again, that is very important. And then class 3, that is mercury and silver, gold and platinum also. The rest, any metal that you can think of, put it into this class. And now you know how you're going to remember these three classes also. Great. So now let us look at one by one the three classes metal nitrates, how they are going to decompose. So first we have class 1. So class 1 was group 1 metals, that is the alkali metals excluding lithium. All of these metal nitrates, they are going to be stable to heat at lower temperatures and they are going to decompose at higher temperatures. What that means is that the metal nitrates below 400 degrees Celsius, there is going to be no decomposition. Between 400 to 800 degrees Celsius, they are going to decompose to form metal nitrite and oxygen, and above 800 degrees Celsius, it is going to be a decomposition into metal oxide, nitrogen and oxygen. For example, let us look at, we have potassium nitrate. So potassium nitrate below 400 degrees Celsius, it is not going to decompose. Between 400 to 800, it is going to decompose to give us potassium nitrite along with that oxygen. And then we have potassium nitrate above 800 degrees Celsius. If we are going to heat it, we will be getting potassium oxide, nitrogen and oxygen. So this is what we have as the decomposition of class 1 metal nitrates. Sodium, potassium, rubidium, cesium, all nitrates are going to behave similarly. But one very important note over here, which you can put in your notes, that in the NCERT textbook, the decomposition reaction that is going to be given is the one, the middle, right? So potassium nitrate on decomposition is going to give us potassium nitrite and oxygen, or all the metal nitrates of sodium, potassium, rubidium and cesium, they will be decomposing to give metal nitrite and oxygen. Okay, so you have to remember this. If a temperature is specified, then you know what is going to be the product. But if the temperature is not specified, and even then you are asked to choose the correct option for the decomposition of the class 1 metal nitrates, please do remember you have to answer it as the metal nitrite plus oxygen, because that is given in the NCERT textbook. Okay, so I hope that will be clear to you. You will not make a mistake. Next we have is the class 2 metal nitrates. So that will be all except class 1 and class 3 metal nitrates. So they will be decomposing on heating, giving us the metal oxide, NO2 gas and oxygen. For example, lithium nitrate is what we started the lecture with. So lithium nitrate on heating is going to give us lithium oxide, NO2 gas and oxygen. And remember, this is going to be a visible gas because this is reddish brown in color. So when you're going to heat any metal nitrate of class 2, you are going to see a reddish brown gas escaping. Okay, so this is one diagnostic test for the nitrates. Now, the next we have is magnesium nitrate. So magnesium nitrate, similar reaction, magnesium oxide, NO2 oxygen. We have zinc nitrate, ZNO, NO2 oxygen. Copper nitrate, copper oxide, NO2 oxygen. Lead nitrate, lead oxide, NO2 oxygen. So very simple it is for you now to remember so many metal nitrates in just one reaction, right? And this beauty is that you are learning it similarly even for the metal carbonates, the bicarbonates, and there are going to be more reactions coming up just this way based upon this classification in my upcoming lectures. Next we have is the class 3 metal nitrates. So class 3 metal nitrates, they are also going to decompose on heating, but this time it is going to be the metal, oxygen and NO2. That is what you have to remember. So metal nitrates of class 3 are going to give us metal plus oxygen and NO2. And this is also what you can remember very easily, that we have the metal nitrates of class 2 giving us the metal oxide, right? And then we had NO2 and oxygen. Now what is happening in this class 3 is that this metal oxide is also unstable, and this also breaks to give us the metal and oxygen. So as a result, what you will be getting is metal, oxygen and NO2, and that is what the product is. So for mercury and silver, what you have to remember is that the metal oxide is going to be unstable and it is going to break down further into metal and oxygen, and that will be the products. Okay, so we have silver nitrate giving us silver, oxygen and NO2. The reactions you can balance, I hope. And then we have mercury nitrate giving us mercury, oxygen and NO2. So this should be now very simple. So let us quickly look at all of these once again together. So we have the class 1 metal nitrates. They are not going to decompose at a low temperature less than 400 degrees Celsius. Between 400 to 800 degrees Celsius, they are going to give us metal nitrite and oxygen. And then it is going to be above 800 degrees Celsius, it will be metal oxide, N2 and oxygen. Class 2 metal nitrates, they are going to be giving us metal oxide, NO2 and oxygen. And class 3, the metal oxide is going to break further into metal and oxygen. So we will be getting metal, oxygen and NO2. So now I think it is going to be as simple as possible for you people. So now let us test our knowledge, how much we have learned from this lecture, and there are going to be questions from the previous lectures also coming up today. So we have, first of all, question number 1, which one of the following nitrates will leave behind a metal on strong heating? This is the AIEEE question, 2003 examination question. So this is for the JEE mains people, but I would recommend all the students even preparing for NEET, you should solve the previous year papers of JEE mains also if you want to excel in your examinations. So we have copper nitrate, manganese nitrate, silver nitrate and ferric nitrate. So which is going to give us a metal? It is going to be a class 3. Class 1 is going to give us metal nitrite. Class 2 is going to give us metal oxide. It is going to be class 3, which is going to give us a metal NO2 and oxygen. So which is going to be a class 3 metal out of all these four? It is going to be silver. Silver and mercury, they are in class 3. So the answer is C, right? So silver nitrate on heating will give us silver, oxygen and NO2. Easy enough, I think now. The next question we have is the products obtained on heating lithium nitrate will be LiNO2 plus oxygen, Li2 plus NO2 plus oxygen, lithium nitride plus oxygen, Li2NO plus oxygen. This is a AIEEE 2011 question and I hope you now all know the answer. Lithium nitrate is going to be in class 2. So what are you going to get? You have to get an oxide, NO2 and oxygen. So the correct choice is going to be B choice. Lithium nitrate on heating, this will be giving us lithium oxide, NO2 and oxygen. So the next one is going to be just a similar one to the one we have just now done as question number 2, but I just want you to have a look at it. The incorrect statement is lithium nitrate decomposes on heating to give LiNO2 and oxygen. Lithium is least reactive with water among the alkali metals. Lithium chloride crystallizes from aqueous solutions, the lithium chloride to H2O. And lithium is the strongest reducing agent among the alkali metals. And this is the JEE mains April 2019 question. So the decomposition reaction questions, they can come as complete questions. They can come as one of the correct or incorrect options. And you should know them all. And that is why we are learning it in this way so that you can remember it easily and excel your examination. So obviously, I hope you all know that the correct option is going to be A, because lithium nitrate on decomposing is going to give us lithium oxide, NO2 and oxygen. As far as the rest of the choices they are concerned, lithium is least reactive with water among the alkali metals. Down the group, the reactivity is going to increase. Lithium chloride crystallizes from aqueous solution as lithium chloride to H2O. This is because lithium, this has a very small size and its hydration is going to be a lot. All right, and then we have lithium, the strongest reducing agent among the alkali metals. Again, it is because of its high hydration energy. All of these things we have already discussed in our detailed course on the S block elements. So you can have a look any of them if you do not understand. All right, so here we are talking about lithium nitrate decomposition. So this is going to be incorrect. So A choice is the correct option. Next, let us look at another question. Yes, this is the one where we started with. So this is what I am building up with my lectures with. Which of the following on thermal decomposition yield a basic as well as an acidic oxide? Sodium nitrate, potassium chlorate, calcium carbonate and ammonium nitrate. And the correct option is C choice, calcium carbonate. So carbonates we learned in one of our lectures on thermal decomposition, and where we learned that the class 2 carbonates, they are going to give us the metal oxide, and along with that carbon dioxide is going to be produced. What will happen for class 1 carbonates and what will happen for class 3 carbonates? You have to watch my lecture. All right, and then potassium chlorate, this is going to still remain pending, so we will not be discussing that today. But again, yes, calcium oxide, this is a basic oxide, and carbon dioxide, this is an acidic oxide. That is why the correct option came up to C. And then we did in the last lecture about the ammonium salts. So ammonium nitrate, this is also having some trick to learn for the different types of anions, classify the anions and learn what is going to be the product form. So in this case, ammonium nitrate is going to give us N2O and along with that water. How is this happening? Again, you have to watch my lecture. All right, so all these are very important lectures. Please do not miss them. And then we have learned today about the nitrates of the metals. So sodium nitrate, this is going to be class 1 nitrate. This is going to give us nitrite and along with that oxygen. Correct option is now C, and what is left behind a discussion from this question is going to be potassium chlorate. It will be discussed in the upcoming lectures, do not worry. So one final question we are going to discuss today. On heating, compound A gives a gas B, which is a constituent of air. This gas, when treated with hydrogen in the presence of a catalyst, gives another gas C, which is basic in nature. A should not be, and this is a JEE Mains September 2020 question. So very recent and so very important. All right. So the choices are ammonium dichromate, ammonium nitrite, lead nitrate, and sodium azide. So this is a question which I asked in my last lecture also when we were talking about the ammonium salts. So here you have two choices from the ammonium salts. Which one is going to give the correct option or not? That is what you will be understanding only when you have watched that lecture of mine. All right. But here quickly, compound A on heating is giving us a gas B, and B on reacting with hydrogen in presence of a catalyst gives C. So first of all, the compound A is giving us nitrogen, which is a component of air, which on reaction with hydrogen in presence of a catalyst gives ammonia, and ammonia is basic in nature. Okay, so this is what we have. So what is going to be, what we want is that the B should be nitrogen. All right. In any of the decomposition reactions where nitrogen is not produced, you know that lead nitrate is not going to give us nitrogen. It will be giving us NO2 gas. So the correct option even from this lecture we get. But what are going to be the products for this? You will have to watch my previous lecture on the ammonium salts. All right. So this correct option is going to be C choice. Lead nitrate is going to give us lead oxide, NO2 and oxygen. It will not be giving us nitrogen gas. So now I come up to the last question for today. Yes, this is a question that I'm not going to discuss, but this is going to be a homework question for you people. This is based upon today's lecture and the lecture that we've done previously on the ammonium salts. So we have to match column 1 with column 2. We have the decomposition of ammonium carbonate, ammonium nitrate, ammonium nitrite and mercury nitrate that we've done in today's lecture. All right. You have to see which of the column 2 choices are going to be correct for the column 1 choice. More than one possible answers can be from the column 2 for one particular choice. For example, if I say A choice, it can be P and Q correct, it can be P, Q, R correct, it can be P, Q, R, S, all of them together correct. So you have to choose accordingly. All right, and you have to put your answers in the comment section. Only then I am going to give you the correct answer. All right, and well, if there are going to be any doubts, do not worry. We will definitely discuss it in the next lecture on the thermal decomposition reactions. So I hope you enjoyed your learning with me. We are going to find up our discussion today. We will be talking back again for more thermal decomposition reactions, more tricks for inorganic chemistry. So please do subscribe to the channel, click on the bell icon so that you can get the notification the moment we put up the next lecture for you. See you again. Have a nice day. God bless you.